Your production FastMCP server uses static token authentication, and you need a clean way to configure the client without hard-coding credentials in your application. We'll set up the FastMCP client with BearerAuth for static tokens, pointing it to your remote server endpoint. You'll see how this configuration automatically handles the authorization header for all requests while keeping your token secure, and why that trailing slash in the URL matters for proper path resolution. For OAuth scenarios, you'd use Auth0 provider on the client side with introspection token verifier on the server. But today, we're focusing on the static token pattern shown here. From FastMCP import client. From FastMCP client auth import BearerAuth. MCP client equals client. https://myserver.com/mcp/ auth equals BearerAuth, your token. This demonstrates the client-side authentication pattern using static bearer tokens. The code configures a FastMCP client with a fixed token that automatically handles authorization headers for all requests, creating a clean separation between authentication configuration and API interactions. The key distinction is that this handles client-side token injection, while server-side verification remains a separate concern. The pattern works by encapsulating authentication details during client initialization. When you provide BearerAuth with a static token, the client automatically includes this token in every request header, eliminating the need to manually handle authentication in each API call. This differs from OAuth flows, which require provider-specific client configuration and server-side token introspection. This approach matters because it provides a straightforward way to implement static token authentication for production APIs. The trailing slash in the server URL ensures proper path joining, while the pattern itself maintains clean separation between authentication mechanics and business logic. For OAuth scenarios, you would use different client configuration with providers like Auth0, paired with server-side introspection token verifier for token validation. Let's break it down line by line. From FastMCP import client. Imports the client class from FastMCP, your primary interface for server communication. This client manages connection pooling, request routing, and automatically injects the bearer token into every request's authorization header. The trailing slash in the base URL ensures correct path resolution when joining endpoints. From FastMCP client auth import BearerAuth. Imports BearerAuth, FastMCP's client-side authentication handler for static API tokens. This automatically injects the configured token into every request's authorization header as a bearer token, handling production-grade static token authentication. For OAuth2 flows, you'd configure the client with an OAuth provider like Auth0 provider instead, while the server would use introspection token verifier for dynamic token validation. The trailing slash in the base URL ensures proper path resolution when joining endpoints. MCP client equals client. Instantiates the FastMCP client with static token authentication using BearerAuth, the standard pattern for API key-based access. The trailing slash in the server URL ensures correct path resolution for all subsequent API calls, while BearerAuth automatically handles authorization header injection for every request. For OAuth scenarios, replace BearerAuth with an Auth0 provider or similar OAuth provider configuration, then pair it with introspection token verifier on the server side for dynamic token validation. This client-side configuration remains production-ready for static tokens, while OAuth flows require complementary server-side verifier setup as shown in the official test client. Pi examples. https://myserver.com/mcp/. This is the FastMCP server's base URL endpoint. The trailing slash ensures proper URL path joining for all API requests, preventing malformed paths. The client uses BearerAuth for static token authentication, injecting the token into the authorization header for every request. For OAuth flows, you would configure the client with an Auth0 provider or similar OAuth provider instead, while the server would use introspection token verifier for token validation. Auth equals BearerAuth, your token. This configures the FastMCP client to use static bearer token authentication for all requests. The BearerAuth wrapper automatically injects the provided token into each request's authorization header, handling authentication transparently. For OAuth flows, you'd configure the client with an Auth0 provider or similar OAuth provider instead. The server must implement compatible verification, static token verifier for static tokens or introspection token verifier for dynamic OAuth validation. This closing parenthesis finalizes the FastMCP client configuration with static bearer token authentication. The client automatically injects this token into every request's authorization header, centralizing authentication while keeping your business logic clean. For OAuth flows, you'd configure the client with an Auth0 provider instance instead, paired with introspection token verifier on the server side. FastMCP client configuration. The BearerAuth client setup handles static token injection into every request's authorization header, maintaining clean separation between authentication and application logic. Server-side token verification uses different providers, static token verifier for development tokens, or introspection token verifier for OAuth production flows. The trailing slash in the server URL ensures proper path resolution for all subsequent API calls.
The token that never changes unlocks every changing endpoint.